I hope you guys enjoyed Miss Deep's cameos as much as I did. I thought they were really entertaining and enlightening, and they added a lot to our lectures. This is Miss Deep's classroom. She's letting us use it. So, like, thank you, Miss Deep, if you're watching this, which you aren't. Okay. No one gave me a thumbs up. That's kind of creepy. I don't know why. But our next one, and this is going to be a little bit of a hard topic, so, like, try and stay with me. I'll attach a lot, and I mean a lot of links at the bottom of the speaker notes because this is really important for you to get down just for general global meteorology and stuff. So today, you might have heard of this. Our topic for now is El Nino Southern Oscillation, which is often abbreviated to enso, and that's the one I'll be using right now. So if any of you are in Spanish, taking Spanish, you know that El Nino means the boy, the baby, which is a little bit of a strange name. Now, I don't actually know what I mean with that. If you know, feel free to tell me. I would love to know, actually. But, I mean, yeah, enso. So, we'll start with a view of the world, right? So, we're not gonna get Eurocentricity out of your head because our view of the world here, our normal map that we have with Europe over here, Africa over here, America, Asia, again, it's very Eurocentric. Europe is in the center. We are not going to be using that map. Now, I'm horrendous at drawing maps. I'm terrible at geography. Owen's great at geography. Unfortunately, he's not the one drawing this map for you. So, let's see. It's like, so we have the United States, like, that's the United States. That's like South America. Australia. And then China is like there. And that's like Russia. That's Alaska. And then you get the idea. It's a little oh, Japan. I forgot Japan. That's Japan. So this is our world map, right? So in this scenario, right? This is our east. This is our west. Cardinal directions get a little bit confusing when you're talking about El Nino and La Nina because, like, technically you can go east to west either way to get to, like, different places. So it's, like, a little bit confusing, which is why I'm drawing this diagram because scenario, east is over here, west is over here. So this is Peru, right? And we have a lot of fish in Peru. This will be important later, trust. There's fish in Peru. Cool? Okay. So normally, I have these things called trade winds, right? And trade winds, they blow all around the earth. The general direction, like, it changes, right? So if I'm going, like, down here, they'll be moving, like, toward Australia in, like this direction, right? Or, like, I have arrows, like, here, right? And then as I go higher up, they change to go, like, this way. And then they go, like, this way. And then up here they go, like, this way. And up here they go this way. Yeah, you get the idea. They kind of circle the earth in, like, these weather cells, Hadley cells, I think they're called. You'll probably learn more about those later, hopefully. I don't, actually. Will we be covering Hadley cells, though? And do you think we should? Okay, he's shown. You're useless. Okay, guys. I didn't mean it. I love Owen. He's my favorite. And I'm not just saying that because he's the one in the room with me. Okay, so but anyways, the one we're going to be focusing on today kind of is this one right here, the one that I'm redrawing. So it goes from, like, Peru to, like, Japan or, like, China area, right? So normally my trade winds blow from east to west, right? East to west. That is the direction they generally blow in. Now, during El Nino, actually wait, before I say that, this is, like, my Eastern Pacific. This is also Eastern Pacific, like, here, and this is my Western Pacific, because this is all, like, the Pacific Ocean, right? This is the Pacific. It's a huge ocean. So generally, East and West Pacific have very different conditions. So my East Pacific is gonna be colder. It's gonna have less rain. My West Pacific is gonna be warmer. It's gonna have more rain. Now, of the two, which do you think would have more, let's say, more capacity to support life? Owen, what would you say? East or West? Pick one. I know you weren't listening. Just pick one. He's just nodding. Okay. So you might think it's the west because it's warmer and has more rain, but you would actually be wrong. My east, see that fish? My east Pacific is the one that supports more life. And this is because of this thing known as a thermocline. People who did Dynamic Planet during oceanography years are like having like traumatic flashbacks right now. A thermocline, I'm very sorry for those of you who are dynamic again. This is not really the best way to explain it, but it'll work for us. So I have layers in my sea, right? Layers like ogres, like onions. So on top is my mixed layer, right? That's what that's called, mixed layer. And then in the middle is my thermocline. And on the bottom is my, oh, I just wrote that in there, it was my deep layer. Very on the nose, right? So my thermocline is kind of the transitional layer between my mixed layer and my deep layer. Now, as you can imagine, my mixed layer is much warmer because all the sunlight is hitting the mixed layer, right? And then not as much sunlight gets the deep layer. So, yeah, my thermocline is my transitional. So as you go down, the thermocline, it gets rapidly colder. Like the temperature plummets in thermocline as you get to the deep layer. So because of a process known as upwelling, I'm gonna write that down. Upwelling, this is important, you should know this. Upwelling is basically where if my surface water, right, if this mixed layer, if my surface water, for some reason, maybe winds blow it away, right? What happens is my deep water upwells, it comes up to the surface. And my deep water is the one with all the nutrients, not my surface level water. So when my deep water upwells, I get more nutrients, I can support more life, right? And now my east Pacific has this thing, it's my thermocline is shallow. So that means it's very thin, right? So you can imagine that when my deep water upwells, it doesn't have to pass through much. It can upwell easier. Now, in my West Pacific, my thermocline is deeper, which means it's larger, which means upwelling happens slower because it's harder for the water to get up. So my West Pacific has less nutrient-dense water as compared to my East Pacific, so that is where all my fisheries are. But keep in mind, we haven't even gotten to El Nino yet. This is all just regular conditions. So during El Nino, what happens is that these trade winds, what they do is that they get weaker or like they reverse, right? So what happens essentially is that these two kind of switch conditions, right? So my Eastern Pacific now becomes like what? It becomes warmer, there's more rain, my thermocline is deeper, my West Pacific has colder, less rain, my thermocline is shallower. They don't completely switch, but like they change their kind of like side, the adjectives that you use to describe them. Now, as you can imagine, this is not great for the eastern fisheries because like a lot of them have disastrous consequences. But El Nino by itself is not necessarily a climate change event. El Nino has been happening and is a global pattern that's happening for years and years and years. The problem is that with climate change, El Nino is getting more extreme to the point where it'll go on for longer than we've seen it go on before. The condition changes will be more extreme, which that's the whole point, right? This has been happening, but when it gets more extreme, that's my problem because we are used to a certain amount of change. And it may just be happening in this area, but this affects temperatures all across the globe. This is not an isolated event. Nothing in ecology, nothing in environmental science is an isolated event. All of this affects weather patterns all around the globe in a bunch of different ways, which I'm not going to explain right now. So, its counterpart, La Nina. La Nina, which means little girl, or little baby girl, which is, again, a little bit of a strange name, but, you know. So I'll move so you can see that. So La Nina is basically, instead of these switching conditions, each of their conditions just get more and more extreme. So my East Pacific, which has a shallow thermocline, cold, not much rain, even shallower thermocline, even colder, even less rain. West Pacific, all those traits that it originally has still apply, right? Even warmer, even more rain, even deeper of a thermocline. So, you know, it's just kind of an extreme version of the conditions they already have, multiplied by 2, if you will. So our Earth kind of goes through phases with these things, right? So we can be in a neutral pattern where we're not having either of those things, or we can be in El Nino, or we can be in La Nina. Currently, I believe we're in El Nino. I think so. From what I remember, we're currently in El Nino, but obviously that can change. So, Yeah, that's pretty much El Nino and La Nina. There's also one more thing I wanted to go over real quick, which relates to these weather patterns. Gulf Stream. Okay, bear with me. I'm gonna draw another truly terrible map. This time it is more Eurocentric. So we have America, that's like Florida, Texas, California. Okay, that kind of looks like a dog. South Mexico is like down here, and then this is like South America, and then Africa is like here. We're gonna ignore the Google Australia. This is like Europe, right? Like those little tendrils. Yeah. Okay. This is not really drawn the size. Europe is smaller. This is, I'm pretty sure. I'm sorry. My geography is really bad. Okay. So basically, the Gulf Stream is this stream of wind that takes water from the Gulf of Mexico, right here, warm water, and blows it up across the Atlantic Ocean. This is the Atlantic, all the way to Europe. And this is obviously very important for Europe because it needs warm water, brings rain with it, which is obviously really important. Again, recent years, I'm sure this was like a big thing a couple of years ago. I'm not exactly sure when. You were hearing about all these changing weather conditions. Snow in Texas. Europe was getting like warmer than ever been before. This is all due to changes in the Gulf Stream. Mostly changes in the Gulf Stream, less than El Nino, because Texas is right here, Europe is here. So again, these are all being affected by climate change. Climate change is changing these weather patterns in real time, and that is very concerning for a multitude of reasons. I think I will probably link a resource or two specifically to the effects that the climate change of this is having on people and stuff. But yeah, that's for sure. I'll cut that.